Okay, welcome to your ed puzzle for today. You should be taking notes with me as we go through. You should be writing down everything. I might be having you turn in your notes after this. I may have already told you that in class, but we'll see. So, first write the title. We're going to be solving equations here. You started in the pair deck. You started kind of exploring with this using the tiles. For the notes today, we're going to just focus on this just in terms of symbols. So just abstractly, we're just looking at variables, and we're going to look at the steps and how to show them. And what do I want to say about that? So you could still think about the tiles here. I might even reference the tiles once in a while, but we're going to just focus on the solving here for this point. And it's really important that you write down the steps the way I show them, because to be able to get credit on your work, you have to show your work that way. The reason for that is that we're trying to communicate steps to an audience, whoever that viewer is. Maybe it's me looking at your work, maybe it's one of your parents, maybe it's somebody, another classmate, or somebody in the future who needs to see your thinking. It's important that we show our work in a particular way so that we're able to communicate clearly. Let's start here. So, solving equations, you did some solving of inequalities, and the steps are going to look the same. So, if I have negative 6x equals 7, I want to get x by itself. So to do that, I am going to do the inverse of what's happening between the negative 6 and the x. Negative 6 is being multiplied by x, so the inverse of that would be to divide by negative 6. So I'm going to divide by negative 6 over here, and I have to do the same thing on the other side. Notice I show this by putting a fraction bar, which represents division. There we go. What you'll see sometimes, I will occasionally do this, is you'll cross out those two right there. The reason we do that is because negative 6 divided by negative 6 is equal to 1. We have now gotten x by itself. We've isolated it because we don't have to write 1x. And on the other side, 7 divided by negative 6, you can just leave that as a fraction. I would write that as negative 7 over 6. Notice that your answer doesn't have to be an integer. It can be a fraction. And notice that the same rules that we learned earlier in the year, a positive divided by a negative is still going to give me a negative. My answer is going to be a negative fraction. All right, on to letter B here. In this problem, we have a variable m, and it's being divided by negative 5 to equal negative 4. Inverse operation. So the opposite of dividing by negative 5 is multiplying by negative 5. The opposite of multiplication is division. The opposite of division is multiplication. So to make this go away, I'm going to multiply both sides by negative 5. I'm going to put this one in parentheses so I don't get confused. Why did I do that? Well, if I multiply by negative 5 and divide by negative 5, these cancel each other out. All I have left on that side is just m, which is what I want. And on the right, a negative times a negative is a positive. So 4 times 5 is positive, or negative 4 times negative 5 is positive 20. Okay. Now, a couple notes here as we move into some more complicated problems here. First of all, combine like terms first. So when we're looking at a problem like this, the first thing I'm going to do is on the left side and the right side, I'm going to combine like terms. Then you're going to undo the addition and subtraction. Maybe I shouldn't have said that before, but undo the addition and subtraction and then do the multiplication and division. So take a moment to write that down. If you need to pause the video, that's fine. I'm going to slide over now. So we are looking here at letter C. We're going to follow those steps. So we're going to start by combining like terms. On the left side here, 2x minus 5x gives me negative 3x plus 7. And over here on the right, 6 minus 8 gives me negative 2. All right, so that's what I mean by combining like terms. You make them as simple as possible. Now I'm going to deal with the addition or subtraction first. So I'm not going to worry about the negative 3 that's being multiplied until I have this term by itself. So I need to get rid of the negative, or the plus 7. So to do that, I'm going to do the opposite of adding 7, which is subtracting 7, and I have to do it on both sides. Notice that I write the step below the line, and I write it underneath the term that I'm going to simplify it with. That makes it easier to read your work and follow what you're doing here. I'm going to come down to the next line, and I'm going to write out everything that's left. So negative 3x, and I like to keep it lined up if I can, equals, this is just a blank spot because these made 0. Sometimes people will circle this, so sometimes you'll see this, just to show that it made 0. That's cool if you want to do that. Negative 2 minus 7 is negative 9. Remember, it's like we're at a negative number. We're going more negative as we subtract 7. Okay, now, this is what I meant about now the multiplication and division comes afterwards. So right here, negative 3 is being multiplied by x. you're going to do the opposite of that. You're going to divide by negative 3. What you do on one side, you have to do on the other side. You have to show that step. Of course, negative 3 divided by negative 3 is 1. That gets rid of that and leaves us with just x, which is what we wanted. And on the right side, a negative divided by a negative is a positive, so this will actually be just positive 3. All right, last one here. You can already see it. Or no, I'm sorry, not last one, but we got a few more after this. So same idea here. We're going to combine like terms first, and then we're going to undo with addition and subtraction, and then we're going to undo the multiplication and division. So combining like terms. 2 minus 7 gives me negative 5. Negative 5 plus 5 gives me 0. So on the left side of my equation, I have 0. That's fine. On the right side, 4m minus 5. Can't combine those because they're not like terms. But I can combine the 4m with this minus 7m. Remember, the sign that's in front of this term is the one I need to use. So 4m minus 7m gives me negative 3m, and it's still a minus 5. Now I want the addition and subtraction to move over first. So we were subtracting 5. So I'm going to go ahead and add 5 to both sides. That will give me 5 on the left, negative 3m on the right. That's kind of a funky looking 3 there. And we're going to now do the division. So again, actually just like this, negative 3x, negative 3m. We're going to divide both sides by negative 3. That gets m by itself. 5 over 3. I'll actually write the negative up here. So negative divided by a positive is a negative. You can show it anyway. You could have the negative in the top, the negative in the bottom, the negative out front. What you don't want to have is 2 negatives because that would actually make a positive number. All right, 2 more questions now. Should get this Ed puzzle in just under 10 minutes, which will be perfect. So let's take a look here, E. We're going to make it just a little more complicated here. So what we're going to do now is we're going to have the variable on both sides. I want to see if you can try these today. So, and my new note for you is this. After combining like terms, which we said was the first thing we're going to do, we're going to use addition and subtraction to get the variable onto one side. Then you're going to follow through just like you did in the other problems. So let's take a look at this. Combine like terms. 4x minus 7. No like terms, we can't do anything there. 6x and 5 are not like terms, but 5 and minus 2 are. So 5 minus 2, I'll write out the entire line here, would give me positive 3. So this is where we're at. We have a variable on both sides. Now, if we're thinking about our tiles, what we would do here is we would take away 4x from both sides. They'd be balanced sets. The way we're going to show that here on paper, and I forgot what color I was using. I was using purples for the addition and subtraction. What I'm going to do is I'm going to subtract 4x from both sides. And this is what I mean by get the variable on one side. You subtract the variable term from both sides, or you subtract the amount of one of them to get them all onto the other side. So look at what's going to happen here. So 4x minus 4x is gone. That's minus 7, so it stays minus 7. 6x minus 4x is 2x. And then we have our plus 3. Now I could have subtracted 6x from both sides, but then I would have gotten a negative 2x. There's nothing wrong with that. I just knew I wanted to have a positive x, so I dealt with it this direction. All right, we're going to go ahead and we are going to subtract 3 from both sides. That's going to give me 2x is equal to negative 10. And your last step here is to get x by itself by dividing by 2. Oh, I should have done... I'm mixing up my colors here. That's okay. So x equals negative 5. All right, last one. Let's see if we can do it in the next 50 seconds here. So a slightly more complicated problem. Those of you that are a little more advanced with this, you might want to pause the video and try it on your own first. Let's see what we get. We're going to combine like terms first. I have negative 3x on the left, positive 5x on the same side. So this is like negative 3 plus 5. That gives me positive 2x. The minus 7 just comes down. On the other side, I have a 12 and a 6. 12 plus 6 gives me 18, and I have minus x. Now here's where we got to think about this here. I want to move this x because this is the minus x. So I'm going to add x to both sides to keep it positive. And I'm totally mixed up in my colors here, but add x to both sides. That'll give me 3x on the left minus 7, and 18 on the right. Now you know how to solve this from here. We're going to go ahead and we're going to add 7 to both sides. 3x equals 25. Ooh. And I'm going to now, to get rid of that 3 there, we're going to divide both sides by 3. So x equals 25 over 3. You could also write that as, let's think, this goes into 24 8 times, so 8 1/3. You could check my work on that. I think that's right. All right, didn't quite get it under 10 minutes, but that's all right. It's under 11 minutes. All right, when you're done with the end puzzle, go ahead and come back to class, and we'll move on when everybody's ready.